Good morning, sir.
Good morning. Are people there? Nobody seems to be there.
Yes, sir. Nobody is there.
Okay, so then we can chat.
Sir, we are live, sir. We are live in YouTube.
I know.
Sir.
Yeah. So we'll wait. We'll wait for the students come. So let me
Yes, sir.
stop my video.
Yes, sir.
Yeah.
And there are two questions from participants, sir. It is given in that sheet. So,
Sheet. Okay. So let me just read it out and then I will answer it. So the first question is, for polymer modified bitumen, resilient modulus is less than conventional mix. How does the design understand this where it requires high modulus? I'm not really sure whether I understand this question, but let me give an explanation about the whole thing so that it will be beneficial to everyone. So, and this is something that in detail we have covered in our earlier mechanical characterization of bituminous material course. I think Dr. Neetu Roy covered that thing, right? Resilient modulus. Yeah. So there are two standards available for resilient modulus for bituminous mixtures. One is ASTM 4123, another is ASTM 7369. IRC 37 refers you to ASTM 4123. Okay. And in ASTM 4123, you measure only the horizontal deformation. You assume a Poisson's ratio, and then you use the elasticity based equation to compute what is called as the resilient modulus. Even the sample sizes are different. ASTM removed that ASTM 4123 code. They stopped it and they replaced it with the ASTM 7369. The 7369 code is a very interesting code because now it asks you to measure not only horizontal deformation, it asks you to measure the vertical deformation. It asks you to measure it on both sides of the sample, as well as it also is asking you to rotate the sample from 0 to 90 degrees and do the test 3 times. And in addition, it also talks you about defining a resilient modulus based on total deformation or to the elastic deformation. So if you sit down and do the computation, you will get around 24 resilient modulus values. Now it is up to the designer what they really need to want. And all these values are given based on 25 degrees centigrade. Now, if you want to do it at 20, 15, 30, 35, you need to work out your protocol. Now, IRC 37 in its own wisdom says, look, I am following ASTM 4123. Okay. And if the modulus values that you are getting are much higher than what is given here, you use the tabulated values. Now, all of us here should understand these are guidelines, tentative guidelines that are given by a standard agency to start you with the design process. They should be understood and interpreted accordingly. One cannot basically take a look at the numbers that you see and say, how is that the polymer modified bitumen has less value or more value than an unmodified bitumen? I would not do that. What I will do if I am doing the pavement design is to go to a nearest lab, measure all these things by hand. Okay, and this aspect of it has already been explained many times in this course. only in pavement design, bituminous pavement design, there is no connection between the mixed design and the structural design. You can do a mixed design, and if you measure the modulus property, it will be something. In the structural design, we assume some properties, 3000 MPa, 4000 MPa, and then we do the design. Ultimately, it is the designer, that is you, who should make the connection, so that whatever mixed design that you do, you go to the lab, measure the modulus value and do it. All the templates, all the figures that are given in IRC 37 are for illustration purpose only, and they make it very clear. So this is my answer to the first question. In the second question, how different crack relief layers such as SAMI, chip seal, and aggregate interlayer behave over the CTP with the granular subbase, because once we provide chip seal instead of aggregate interlayer, we are getting the critical horizontal strain in IITP output as compression values. What does that indicate? Okay, so there are two answers to these questions. First and foremost thing is, a chip seal is not a structural layer. Okay, so please understand that, number one. Number two is, IIT PAVE should be carefully used. Not only IIT PAVE, for that matter, any software that is based on layered linear elastic theory should be used very carefully. If you are going to have inverted pavement, if you are going to have pavements in which the subbase layer has more stiffness, more modulus than the base course layer, the layered linear elastic theory programs may not necessarily give you the correct value. What you should do is to either use softwares such as Circly or MEPAD or Bizarre or Everstress. These are all some of the pavement analysis and design softwares that are developed by different agencies. Some of them are freely downloadable, and you can use it because they don't use layered linear elastic theory. So you cannot have IIT PAVE in your hand and then try to design all these complicated cross sections. Okay, I hope Dr. Padma and Dr. Neetu Roy, I hope I answered the questions. If you want to add something, you are most welcome to add.
So nothing to answer, but this is the question which was asked even last interactive session. Like if there is no granular layer above a cement treated base, how to take about the design with IIT?
Yeah. See, because if they have worked out gone through IRC 37, and we have worked out many examples, there is no example that will be shown as part of IIT PAVE. Okay, so one should be very careful when these things are introduced, because if the students understand the basic assumptions that are made in layered linear elastic theory, we always assume E1 greater than or equal to E2 greater than or equal to E3, and so on and so forth. So when you change that order, you are going to get these kind of scenarios, and engineer should be savvy enough to interpret it accordingly and do it. Okay, so please do not stretch the limits of this software just because it is given as part of IRC, and IRC says it very clearly.
So we request a student to post any question. You can use chat box for this, or if you want to speak, please unmute and speak.
Yes, maybe we know the question paper for exam. Srinivasan is asking. The question pattern for the exam is the NPTEL has a fairly standard thing. So there is something, that portion which is mostly objective type, that is something like recollect from the lectures. So there is one component. Another component is this is about, you had many assignments, 12 weeks, you had 12-week assignments. So there will be some assignment questions that will be asked. Then there will be some short answer questions. Since this is going to be a paper-based question, there is going to be a short answer question. And there will be some long answer questions that may be theory or that may be problem-based. But all the necessary information that is needed for you to solve this will be provided with you. Okay, so I hope I answered Mr. Srinivasan here. Anand Kumar Jaiswal has a question that says, you said in a lecture that you will be providing us a design report. I will surely do it. I haven't. I have to send it across to NPTEL and then they will share it. This will be a lot more comprehensive that a design report. The design report is something that was done by a student like you when I teach this analysis and design of pavement at IIT Madras. So this is typically taken as an MTech level course. So I will share that design report with you, and it will be, you can use it for background information. Okay, it is kind of going to give you lot of details about how to analyze the traffic, how to do the stress analysis, how to proof check given any pavement cross section. So I will surely do it. I hope Mr. Anand is satisfied with the answer. In the last lecture also, I'm sure you have watched the last lecture, I outlined a lot of design projects. Do any of you here who are here? Because I could see only 13 participants, out of which 40, means 6 of us are from IIT Madras, so 7 of us rather. So do you have any question related to that design project? Do you have any clarifications that you want to ask? Okay, doesn't matter. If you have any question, please feel to email me. Email me, I will take care of it. I will respond. You don't need to email any of the co-teachers here. Email. And it will always be useful if you also go and watch the previous 12-week course on mechanical characterization of bituminous material. It is pitched at a level in which you can spend a lot of time thinking about the various techniques, issues, models that are needed for characterization of bituminous material. It will be very, very useful and come in handy.
So, good morning, sir. I'm Srinivasan.
Yes, sir.
So, from the IIT PAVE analysis, we have given some standard load, sir, 20 kilonewton. For the analysis, is it a single load or it is a repetitive load during analysis? How it is taken?
Nivita, would you like to go?
Yes, sir. So it is the standard load that we are placing on the pavement, and whatever is the total allowable number of repetitions or the load carrying capacity for the pavement. We are determining it in the equivalent number of repetitions of this standard load. Let me give you explain with a specific case. Let us say for design, if you take the actual traffic spectrum, you have different type of axles. You have a single axle dual wheel. We have tandem axles, which are 2 axles. You should have learned about all these things in the lecture. We have tridem axles. Again, if I take single axle dual wheel, it has different axle loads, right? It could have 8 tons, or it could have 10 tons, different loads, right? So what when we do the design, when we estimate the load carrying capacity of the pavement, it is very difficult to specify in terms of these individual load groups or individual axle configurations. So for the sake of convenience, what we do is we convert all these axles into equivalent number of standard axle repetitions. So if I have a wide variety of axle configuration and axle load, I use different kind of conversion factors, convert all of them into the number of repetitions of the standard axle load. So now when we do the stress strain analysis, we evaluate the strain only for one repetition of the standard axle load. So from the strain value that we get, we input them into these distress transfer functions. That will give us how many number of repetitions of this standard axle load we can allow on the pavement before it reaches these failure criteria, like 20 mm rutting or 20% cracked area. So when we do the design, when we evaluate the strain, it is for only one repetition of the standard axle load. But when we compute NF and NR, it is how many repetitions of this standard axle load I can allow on my pavement before it fails.
Yes, ma'am.
So
Okay, thank you.
Yes.
Yeah, understood.
To answer this question from Rohit, because I mentioned about various design projects. This is something that I will just take upon what Dr. Nivita just now mentioned. Now you have some design templates that are given in IRC for 35 degrees centigrade AAPT, right? There are also 2 distress equations that are given, one for rutting, another for fatigue, and each of these equations are given for different levels of reliability. Now, you also have modulus parameters that are given to you. Now, what I meant as proof checking is, can you go to KenPave or IIT Pave, put these thicknesses, put the material properties, apply the load, the tire pressure, then after that, compute what exactly is the tensile strength. Now, what is that you are trying to do? You have been given a cross section and you are trying to find out what is its structural capacity. Okay. And how will you estimate the structural capacity? How are you going to estimate the structural capacity? By finding out this required strain. And when we are talking about structural capacity, we are talking about its ability to take the load for a terminal condition of rutting or for a terminal condition of fatigue, and these are all agency dependent. Okay. So now you evaluate your cross section. After having done that, let us say your field people come and say, you know what, I have done this traffic survey, axle load distribution, and so on and so forth, and I find out that these calculations that I do, our cross section should take 30 million standard axles in 80 kilonewton load. Now they want you to check whether it will be 30 million or not. So you take these 4 equations, 2 for rutting, 2 for fatigue, with a different reliability, and then you check whether the values that you will get exceed the 30 million standard axle. If it exceeds, then you can confidently say that the actual load that is going to come only is this much. The allowable load for this pavement cross section is a lot more than that. So it is fine. Now this is very interesting because you have 2 reliability. Let us say if one cross section is not meeting the 90% reliability criterion, and in fact, if you look at your distress equations very carefully, you will see that for the reliability, that only one number will change. So you can say 3 times or 4 times. You can actually do the math and find it out. Then you can say it may not meet the 90% reliability, but this is a district road. I am fine with 80% reliability. So this cross section is fine. Now you can have another interesting scenario that it meets rutting, but it does not meet fatigue. What will you do there? Again, you can say, my main criteria here is only going to be rutting. It is not really fatigue. So even if it is not meeting, it is fine. One more interesting scenario is it is way too safe in the sense that, you know, your requirements is only 30, the cross section is giving you 60. Why would you want to do that? You don't want to do that. So now you can reduce the thickness. And this is where the constructability aspects will come, because if you do the mixed design, your construction engineer will say 3 times the nominal maximum aggregate size is the single lift. So that means if you are using 13.2 mm, your lift thickness has to be 40 mm. So you can't do anything much there. So then you will take a look at TBM. Maybe I can reduce the thickness here. Okay. So this opens up a lot of opportunities for you to think about, do the calculations, understand what it is. And that is what I mentioned as proof checking. So if Professor Padma would like to add something here, because she taught you IRC 37, I request her to add her feedback here. Padma, you are muted.
I'm muted.
Padma.
Sir, as you said, the reliability matters here, depending on whether we are going for 90% reliability or 80% reliability. Sometimes rutting transfer, we may satisfy with the rutting conditions, we may not satisfy with the fatigue damage conditions. So we take a call over there as a designer. So we decide on what is our requirement, and we change the cross section depending on the requirement.
Rohit says thank you. Thank you so much, Rohit.
Sir, one more doubt.
Yes, sir.
So this IRC 37, if I say I am designing for a CBR value of 5 and for 20 MSA, I am designing the IIT with the full life period, say 20 years. Then if I go for a stage construction, the same section is failing actually. So for 20 MSA and CBR 5, my BC is 40, DBM is 100, WMM is 250, GSB is 200. It's coming safe in for 20 years. But if I go for stage construction, this section will fail in rutting, sir. Actually, should come less now, sir.
But how did you do the stage construction?
They're given some option now, sir.
No. If you can give more details, maybe, you know, if you can write an email to one of us.
Yes, sir.
Okay, then we can walk you through the whole thing. So when you do the stage construction, see, because to just give a simple example, we won't change the thickness of the granular base and subbase. We'll keep it as it is, right?
Yes, yeah.
So let us say you are talking about 20 MSA, so you want to do it for 10 MSA. So when you say stage construction, are you talking about?
Yeah, stage construction means my bituminous layer is designed for 5 years. My
so
granular
5 years
layer is designed for full design life.
Granular layers, you won't touch it. Whatever is the granular
Yes,
layer that you are going to provide.
Yeah.
So the bituminous layers, you are going to do it for, let us say 5 years. So what happens after that?
But the same section I'm designing for this 20 years life from 40 mm BC, 100 mm DBM, 250 and 200 granular. The same section is failing for the stage construction.
Okay, I am not sure whether I understand. So if you can share the details, email one of us, then we will just work out the calculations and send it back to you.
Okay, sir. Yes,
okay.
Thank you.
Like what is the modulus value of each structure you considered?
I will
And
send the details.
VDF values, yes.
We'll send the both design, ma'am.
Yeah.
Okay. Thank you.
Sir, I have a doubt.
Yeah.
Sir, for polymer modified binder, see, generally modulus will be less, no, sir, but it performs better than normal binder. So how can I understand this?
I think I answered this question. Probably you just joined it a little bit say late. So when you say modulus, you are talking about the resilient modulus of the polymer modified bitumen or the mixture.
Yes, sir. Yes, sir.
So you are talking about the resilient modulus of a mixture made with polymer modified bitumen.
Yes, sir.
So how do you say that its value is less? So are you referring from the IRC values or have you measured it by yourself?
No, sir. From the formula, I thought stress by recoverable strain means, so recoveries are high for the polymer modified binder. So denominator is going to be high. So I thought the value will be comparatively less.
It should be more, right?
Sir, shall I answer, sir?
Yeah, please go ahead.
I think you are saying it's based on the definition of resilient modulus, right? Stress by recoverable strain. But
Yes, ma'am.
the definition has stress as well as recoverable strain. You are talking only about a recoverable strain. So you please measure a resilient modulus in the laboratory and check whether the resilient modulus of polymer modified binder is less than conventional unmodified binder. See, you have two factors over there. So one is stress and other is recoverable strain.
Yes, ma'am.
Okay. Uh,
No,
Sir.
yeah. So let me make this clear. Okay, so if you are talking about resilient modulus, and you need to understand that you need to actually measure it.
Yes.
Number one. Number two is the resilient modulus definition as is given for bituminous mixtures when you are testing it in indirect tensile mode, repeated load indirect tensile mode, talks in terms of the applied load, the deviatoric stress, divided by the recoverable axial strain. So you are saying since the polymer modified binder will recover more, the recoverable axial strain should be what was that you said? It has to be less or something like that?
Yes, sir. Yes, sir. More, sir.
The resilient elastic strain.
Strain is more, sir. Recovery strain is more, sir, because it is a polymer, so it recovers more. That is what I understood.
No. Normally, what we do when we do the repeated load indirect tensile. So let me try and see whether I can connect my device and then show you whether I can write it here. But okay, so that will take time. Anyway, so please take a look at how these things are defined. So in a resilient modulus test, you are talking about a total strain and the resilient strain. Now the resilient strain is a component of the total strain, and for the applied load, how much is the total strain and how much is the irrecoverable deformation basically depends on the temperature and the applied load. Okay, so it is not straightforward to say that a polymer modified binder will recover more. If it is going to recover more, that elastic strain that you are seeing, okay, so that is going to be different compared to an unmodified binder. So the modulus values have to be different. So I would not make those statements. What I would actually do it is you may want to take a look at one of our earlier NPTEL course in which we talk about how to measure resilient modulus of bituminous mixtures and the definition of total strain, irrecoverable strain, recoverable strain, how they are computed, all those things are the same. So if you still have any query related to that, feel free to send an email and we will try to find the answer.
Okay. Sir, another doubt, sir.
Yeah, go ahead.
Sir, in the binder, if you go for LAS test, so for soft binders, NF value will be more, no, sir.
You are talking about the linear amplitude sweep test.
Yes, sir. Yes, sir. Linear amplitude sweep. The fatigue test, sir.
No, that's not true. I mean, if you have a rheometer and if you run it, see, because basically what they do, they use the viscoelastic continuum damage mechanics principles to compute the NF value. The test consists of two parts. In the first part, you compute the viscoelastic properties, linear viscoelastic properties. And in the second part, you try to find out how these linear viscoelastic properties deteriorate when you are doing an amplitude sweep. You estimate it at a different strain intervals. Okay. I think Padma, would you like to add something to this? Because you have done few things in this. He is talking about LAS test.
LAS test.
Yeah.
So we do a frequency sweep test in a linear regime and we find out a linear viscoelastic properties. So we do this last test in a two scale, one in the linear regime to find out a linear viscoelastic properties. And in another test, so we ramp the strain value from 0.01 to 30%. So, and we compute the fatigue damage based on this ramped strain result. So when we compute this, so there, see, when you keep on increasing your strain value, the torque of this material will fall down. Okay, so it is not that the soft binder have the steady torque, or it, depending on how the torque or a peak stress value varies with the percentage of strain, the fatigue life is going to vary. Okay, so it all depends on how the peak stress value falls with the number of cycles or with the percentage of strain value. Okay, so we cannot give a direct relation that the soft binder has a more fatigue life. It all sensitive, like how sensitive it is to an increase in strain amplitude.
Okay. So we cannot tell soft binder is having a higher fatigue life in terms of that binder compared to that of the hard binder.
No, it's not that direct.
Okay.
So we increase the strain amplitude. So it is all depends on how the material is responding to the increased strain amplitude. So when you increase the strain amplitude, we expect the stress value or a torque value to reduce. So as the damage occurs, so it's not the direct relation that the soft binder has a more fatigue life or a steady shear stress value.
Ma'am, generally when we say soft binder is, I mean, it can expand more. So we generally say it is having a higher fatigue life, or in the design also, when we want to increase the fatigue life, use the soft binders. I mean, I have listened these kind of things, so that's why I asked.
Nivita, would you like to answer? You are muted, Nivita.
I think you can answer this question.
Okay. I mean, I don't know where you listen to all these things. I mean, I honestly don't know how to answer this, because this way of thinking that a soft material will have better fatigue life is what should I say? Like, pardon my language, I am online. It's quite juvenile. Okay, you should fatigue for bituminous mixtures, fatigue of bituminous binders are a lot more complicated than what we understand. So to give a very serious answer to this, I will just give a quick background. people did not worry too much about fatigue when all these codes were written. So you talk about viscosity, you talked about 60 degrees centigrade viscosity. Then you moved into PG, and when the PG came, they started with the G star sine delta kind of a parameters. And when it comes to the fatigue, first thing, they were not very clear about what was the temperature to use. Where should I test for fatigue? Okay. If you ask me, in India, I will say do it at 20 degrees centigrade. Okay, so you will ask me like, how do you know? I said, that's my gut feel. I know this material, I know this feel. 20 degrees centigrade is what I would use. But then what the Americans did when they started with the PG, they came out with an interesting temperature measure between high temperature. So they worked out high temperature very carefully, beautiful, one of the best data. Similarly, low temperature. But when it comes to fixing for the intermediate temperature, which is where the fatigue damage is going to happen, they said take the difference divided by 2, add 4 degrees centigrade, something like that they came out with, because this is based on their data, their validation. So now when our people took this and wrote IS 15462, even for a material having a PG of 82, when you apply this formula, you are checking for the fatigue in 40s, 30s and 40s, which is not really a smart thing to do, because if you actually measure those material, especially very heavy dosages polymer are used to get your PG 82, they will have a PG of 15 or 14 degrees centigrade when it comes to the intermediate temperature. So this is as far as the first explanation about the temperature and the grading. The second thing is, when in fatigue, a lot of interesting thing happens. When you apply a load and when the load is removed, there is stress relaxation happening. The material heals. So that is why we are unable to, and when I say we are talking about all the pavement engineers in the world, are unable to come out with a precise and clear spec for fatigue. If you look at Super Pave, they will tell you for rutting, do the test at 60 degrees centigrade, flow number, this much should be the value for this much million standard axles. All of them are well set. But when it comes to the fatigue, there is a problem. The Europeans will do it with the 4-point bending. They swear by 4-point bending. Americans left fatigue as it is. They said G star sine delta is fine. They went into the fatigue fracture part of it. Semicircular bend, ABCD, dent, ideal CT. So many tests have been worked out related to the fracture part of it. But when it comes to the fatigue part, the only best thing that we have is the linear amplitude sweep test. Earlier, they used to do what is called as a time sweep test, and then use the same ideas that you borrow from mixtures. Okay, what is your fatigue like? 50% reduction in the modulus can be taken as the fatigue like. So fatigue is confusing, because what happens is, and this is something that we discuss, all of us in our classes, is there is a creep fatigue interaction actually take place. So when this interaction is taking place, life is not fairly straightforward. So that is why when you say, can I use a soft binder and enhance it? That may not necessarily be the correct way. So what I would say is, fatigue is something that we need to think about it, talk about it, understand it a little more carefully, because the microstructural mechanisms are a lot more complex here. And as of now, the best bet will always be in terms of testing it with the mixture and not unnecessarily trying to relate it with the binder. And what temperature you should test, whatever you think is the lowest temperature in our country. In our country, the lowest temperature, I would take it as like what, 20 degrees centigrade is a good deal. 20 degrees centigrade, if I am not talking about the Himalayan region, Jammu, Kashmir and all those places where the air temperature can go below 0 degrees centigrade at times. Whenever the air temperature is about 0 degrees centigrade, I will stick to 10 or 20 degrees centigrade, do the testing at 10 hertz frequency. Even 10 hertz frequency will be an overkill, because that corresponds to 60 or 80 km/h speed. So, but having said all those things, when you want to characterize fatigue, do the testing at the mixture level, test at 20 degrees centigrade, 10 hertz frequency. Even a simple measure such as 50% reduction in modulus will give you some idea about the different binders that you are looking at. I don't know whether I answered your question, but
Yes,
this
sir.
is the best I can do at this time.
Yes, sir. Yes, sir. Yes, sir.
Okay,
Yes,
right.
Thank you. Sir. Thank you.
Yeah. Sagar says something about overlay design. Would one of you want to take it, Padma? Yeah.
The design.
Overlay design.
Sir, I'm reading the questions.
What is IRC 115 used for, Mr. Sagar? Can you just type your answer?
And it is also says like Poisson's ratio of 0.5.
Yeah. But what does IRC 115? I mean, I would like to hear the reply from Mr. Sagar. Why do you confuse IRC 115 with IRC 37? What is KGP pack for? This is to estimate the remaining service life using a falling weight deflectometer, correct? You can type yes or no. Yes. Okay. So that is a tricky issue. Right. Okay. So I will tell you what exactly is the problem here. When you are doing, see, first and foremost thing, the KGP pack, there are many back calculation procedures that are followed. Most of the falling weight deflectometers which you use will have their own software that will use it for computing the back calculation. Now, these are all estimates that you give. Okay. Now, another simple question that I would like to ask, if you don't know, it is fine. What does 0.5 Poisson's ratio mean? If you don't know, it is fine. You can just say, I don't know. Then I will answer. Okay, I am going to assume that you may not know the answer. So it talks about an incompressible material. So you are basically talking about a material which has been subjected to repeated load. And it has more or less densified. There is not going to be substantial change in the density of the material. So most of the people, when they try to do this back calculation, especially for most of the layers, would try to use a Poisson's ratio corresponding to an incompressible material. Okay, so that is why you use 0.5. But having said that, the back calculation procedure that is listed in IRC, especially used in KGP pack, is kind of very simple actually. The back calculation procedure can be very complicated. Why it will be complicated? So let us say you have 3-4 layers. What do you do in your FWD test? You subject it to some loading and then you measure your deflection load. Now, when you do the analysis, you need to have an idea about what was the original thickness, what is the range of the modulus values that were used in the initial design. Now you have done your pavement design, and I do not know whether you are a practicing pavement engineer or a student. Can one of you answer me here? Do you know the modulus value of any national highway stretch in which a bituminous concrete or dense bituminous macadam is used? Has anyone measured it? Because what do? You read IRC 37, you take AAPT as 35 degrees centigrade, and you say 10% is the CBR, then you read from the chart, and then you go and use it. if you verify whether that is 3000 MPa, then when you give in the back calculation procedure, because you need to give bounds, and the numerical optimization will keep iterating to find out how much is the actual value. The current value that is estimated using this optimization procedure will depend on the initial value. The initial value is not measured by any of us. So we provide some value, and then based on that, it is estimating something. So exactly, we hardly ever use the exact MR value during road construction. So if you say that clearly, then what is the point in doing a back calculation procedure, taking the FWD to the site and hitting the poor road and then collecting the data if we can't give the range of the values? So that means you need to measure your material properties. Okay. So there is a question by Rohit Kumar. I think Dr. Neetu Roy can take it. This is about fixed vehicle approach by considered. Can we do the same with fixed traffic approach?
Yes, sir. Yes, sir.
Yeah.
The question is whether we can be designed by fixed vehicle approach by considering insult. Can we do the same with fixed traffic? See, when I say fixed traffic approach, you essentially are trying to design based on one load, the heaviest load or the most critical load that is going to come, right? And you're not considering the number of repetitions. So in highway traffic, why do you want to go with a fixed traffic approach? I didn't get the question. Rohit Kumar, can you elaborate like why you think that a fixed traffic approach is necessary, or maybe it's better? See, essentially you consider only one load, right? And the number of repetitions of the loads are not considered in a fixed traffic approach. So this was okay if you had most of the vehicles are of the same class and carrying the same amount of load, as in the case of a runway payment. Okay. Earlier, when the runway payment, when the heaviest load is the contributing one, then that was okay. Rohit, can you?
Yeah. So let me just add to whatever Dr. Neetu Roy mentioned. So let us understand how the highways are designed, how the runways are designed. In the runway, you have clear-cut idea about the axles, the configuration of the axle, the type of aircraft that will land there. And in fact, right now I am teaching this airfield pavement design, in which we look at each and every aircraft, their gear combinations, how they are placed, where they are placed. And in fact, they will even go to the extent of how much is the lateral load that is transferred during a specific deceleration maneuver. So things are very precise. So when you are trying to design, finding out those equivalent single wheel load, we normally try to answer 3 questions. Okay. What are those 3 questions? The first question is about what kind of a layer theory you are going to use. Single layer, 2 layer, or 3 layer. Second is, what is the equivalence you are looking at? Either stress or strain or deflection. No damage. Okay. Please understand, no damage. Stress or strain or deflection. The third question that you want to answer is, where is this equivalence established? Most of us who are trained in pavement engineering will say, oh, if I am interested in fatigue, I would like to check the equivalent strain at the bottom of the bituminous layer. Correct? So then what you will do, you will have another equation that will relate this strain, some kind of a shift factor equation, with the damage. So in those days, when aircraft runways were being designed, they will pick one designer aircraft and then try to relate the remaining aircraft in terms of this aircraft. So for instance, you can say C-35. So if you say A330, so you will say how many passes of C-35 is equivalent to how many passes of A330. All these ideas works out very well when you have 10 to 15 types of vehicles, their landing gears, everything known. Now, when you come to the highway, you basically have no idea about what are the axle configurations, what is the load that is going to be, and how many repetitions are going to come. So in that context, you really cannot do it with the approach that we are talking about as far as the runways are concerned. You have to do it only in this. But having said all those things, these days, neither we follow fixed traffic nor we follow fixed vehicle. What we do, we have computationally very efficient systems. We take the actual load, apply it on the pavement, compute the strain, use it to compute the damage, and keep doing it for all the type of loads that we are talking. I hope we answered Rohit's question.
Yes.
Yeah. Most welcome. Any other question? I think this session is for 1 hour, right?
Yes.
Do we have any other questions from anyone? I think we have only 12 participants. Shall we wait for some more time?
Yes, sir. So I think no more questions because there are only 4 external participants now.
Yeah, so in that case, I think we can leave, or do you want to wait for some more time? I think we can leave. Padma, what do you say? Padma, you are muted.
So we'll close, sir.
We will close. Okay. So thank you so much. Wish you all the best for the exams. Do well. And if you need anything, please do let us know. Thank you. Thank you all.
Thank you all for joining.
Thank you.